This is the lab video for Lab 4, using regression for prediction. One of the main reasons we study the relationship between two quantitative variables is to try to determine if the value of one variable, the response, can be reliably predicted from the value of the other variable, the explanatory. First, we must determine if there is a relationship, association, between the variables, and if so, what is the nature and strength of that relationship. The setup. We will study the relationship between the distance you guess between two objects and the true distance between those two objects. If there is relationship between our guesses and the true distance, then we will use our guess distance to predict the true distance. Data collection methods update for online labs. Traditionally, if we are meeting in person, then during the lab, we'll go out as teams of 4 to measure distances of certain items. Since we are all at home, we need to modify the lab manual, so make sure you follow this video as an instruction, not necessarily the step-by-step instructions of the lab manual. So stand in the middle of some area. It can be in the middle of your room, or other places. You can go out and stand in the middle of a yard. It's up to you. Mark where you're standing. This is your reference point, and it needs to be marked as it will be where you start your measurements. Identify 11 objects you can access in a straight line and fill in the second column of Table 4.1 on page 29. The object description column. Some objects should be in front of you, behind you, and to the side of you. Some objects should be close to you, and some should be further away. The only restriction is you will have to be able to measure the straight distance between the reference point and the objects. Standing at the reference point, guess the distance in feet from the reference point and the objects, one at a time. Write down your guesses in column 3, guess distance, in table 4.1. Don't worry about how accurate your guesses are. There is no prize for being a good guesser. After all guesses are made, find the true distance between the reference point and the objects, one at a time, in a straight line. You can use a physical measuring tape if you have one, or there are some apps you can download to your phone that will do measurements between 2 points. For example, a free app called Tape Measure. Take 3 different measurements for each object. Put all 3 measurements in feet in the 5th column, your team's measured distance. We need 3 measurements because we want to make sure we don't have a big mistake in the measuring step. And then find the median of the 3 measurements and put it in the 6th column, true distance. At this point, make sure you have all but the teams to measure distance column filled in on table 4.1, page 29 in the lab manual. Teams to measure distance should be blank. Answer question 1 in the discussion question on page 30. Modify question wording due to we are all online. Why might the measurements in the true distance be different for different measurements even though we are measuring the same distance? The data collection is now done, and we will move on to the data analysis phase. So log in to StatCrunch and enter your data. 1 column for guesses and 1 for true measurement. Don't include the 11th object in this part. You should only have 10 data points in your StatCrunch spreadsheet. Create a scatter plot of the data and add the y equal x line to your scatter plot. Under Graph, and then click Scatter Plot, select x variable as guess, select y variable as true, and go to the overlay function of x and simply typing x. Hit Compute. You can now answer discussion question 2 and 3 based on the scatter plot. Make sure you keep a copy of the scatter plot with the line y equals x on it, because you will have to provide this to me when you turn in your work. And note that the line y equals x is not the line of best fit. So read the lab manual and will tell you what this line represents. Perform regression analysis in StatCrunch. First, perform a simple linear regression. Go to Stat, and then Regression. Click Simple Linear Regression. X is guess, and Y is true. You must provide a copy of the regression output to me. Then you will perform a quadratic regression analysis. Again, this is only for the lab. You won't use it for exams or lectures. Go to Stat, Regression, and Polynomial. X is guess and Y is true. So polynomial, the order by default is 2. You don't need to change this. And you must provide a copy of the regression output to me. So table 4.2, page 30. Don't forget the second screen in the regression output contains a scatter plot with a line of best fit. So once you get to the first screen with all the numbers, just hit the over arrow and it will take you to the scatter plot. The line or curve on your scatter plot is your best fit. Error standard deviation S. On simple linear regression results is estimate of error standard deviation. And on polynomial regression results, it's root MSE. 95% prediction error is 2S, calculate as negative 2S to positive 2S. At this point, you should fill in table 4.2. Let's move on to table 4.3. Chosen model, linear or quadratic. You will choose which one is better. Basis for model choice. Check the given reasons that applied. And chosen model's prediction formula. Give the prediction formula for the model you have chosen. Note that the formulas are given in the regression output. Linear regression have the form y equals a plus bx, and then quadratic have the form y equals a plus bx plus cx squared. Calculate your prediction for the 11th object. Plug in your guess for the 11th object as x and solve for y. This is the reason why you need to leave the 11th object blank. Previously. True distance y for the 11th object. Note that the book states that the lab instructor will provide this, but this is not the case since the lab was done at home, so you should have to have the true measurements to the 11th object. Calculate the residual for the 11th object. The formula is in the lab manual. And answer the question, does the residual fall within negative 2s and positive 2s from table 4.2 for the model you have chosen? Finishing up, answer discussion questions 5 and 6. Read the content in prediction error section of lab manual to help you answer question 5, and then the reality check section to help you answer question 6. You need to turn in all necessary work to your lab instructor. That includes the output from StatCrunch, scatter plot with y equals x line on it, and the regression output and scatter plot for simple linear regression, the regression output and scatter plot for polynomial regression, and table 4.1, 4.2, and 4.3, except the team to measure distance column should be blank. Also, you need to answer all discussion questions 1 to 6.